Hello. In this video, you're going to see everything you need to know about series, including some application problems. Okay, so we learned that sequence is just a list of numbers. A list of numbers, ordered list of numbers, of course. We denote them a first, a second, a third, and so on. And then you want to add them up, and then it becomes a series, the sum of terms of a sequence. That's what we call a series. Instead of commas, we just put pluses, and now it's a series. So we will talk about notations first. For the word series, we are using letter S, and S indicates the sum of first few terms. For example, S1, okay, it's not a sum of first term, but it's just the first term, 1. S2 will be the sum of the first two terms. So in this case, it will be 1 plus 3, which is 4. S3 will be 1 plus 3 plus 5, which is 9, etc. So Sn, maybe I should write it down here in general. Sn is the sum of first n terms, a first, a second, all the way until an. Okay, first n terms. The next big important question is, how do you calculate the sum of first n terms? As you will see, it's important question practically because many realistic tasks require you to add a bunch of terms of a series. Now, for arithmetic series, the derivation of this formula is very simple and visual, and it's worth noticing because the formula for arithmetic series is not included in the reference sheet on your Regents exam. So pay attention, and if you forget it, it's really easy to restore it. So if you look at this example of a series, so it's arithmetic series. I am adding 1, 2, 3, 4, 5, 6, 7, 8 terms. So this will be S sub 8. And I want to calculate it. So I am noticing that if I add first and last, second and next to the last, third and next to the last, and the middle two terms, I'm going to get the same numbers. 16 every time. 16 here, 3 plus 13, 16, 5 plus 11, 16, and of course 7 plus 9 is also 16. So I have 16 couples. Oh, I'm sorry, I have 4 couples. Each of them equals to 16 together. So I need to take 16 4 times. Now, what is this 4? How can I generalize it? 4 is half of the number of my terms. I have 8 terms here, so it gives me 4 pairs. In general, my formula will look like this. Take first term, add the last term, and multiply it by half of the number of terms. Let's take an example. Suppose you have a sequence, example, 8 plus 5 plus 2 plus ... and then minus 19. Add up all these numbers. So first you're looking for patterns, and you're noticing that this is 3 less, this is 3 less. So usually, like, it's convention that if a pattern repeats first couple terms, then you assume that's the pattern. So you know it's an arithmetic sequence. What do you know about this arithmetic sequence? You know the first term, which is 8. You know D, which is, you go down by 3, so it's negative 3. You don't know N, but you do know the last term. So you don't know what term is it, but you know it's the last one. So in order to use the formula, we need to figure out N. How to do this? You know that negative 19 is the nth term. So the nth term formula may help. Either you remember it or you don't. it's not hard to kind of restore it. Remember when we derive the formula of an nth term, the reasoning is like this. You start with the first term, and then you add d, and then you add d, and then you add how many d's? One less than the term number. So you have all of this information given except n. So you substitute negative 19. You will get, if you start with the first term, your d is negative, so it will be minus 3 times n minus 1. And then you solve this little equation, and you do it on your own, and then you finish and check. All right, so I got n equals 10. So now we can just substitute. And now we know it's s sub 10 that we need to find. So we know there are 10 terms here. Oh, but where's my formula? So I raised it purposefully to show you how you restore it if you don't exactly remember. So visualize this diagram that was right here with the little rainbow. I call it rainbow method. And just think, okay, so we added the first term. I'll write the formula first so we could use it. And the last term. And this sum repeats every time for every pair. How many pairs do we have? Number of terms divided by 2. So it's really easy to restore this formula without really memorizing it. So now it's easy. You just do first term 8. Last, we know it's negative 19. I'm adding negative 19, so it's subtraction. No, I don't want to divide this by 2. It's even. It's odd. Instead, I'm going to divide 10 by 2. So that's negative 11 times 5, and it's negative 55. Finished. If you want, check it. It's not that many terms to add. All right. The formula for n terms of geometric sequence is much harder to derive and much worse to remember. So, and luckily it's given to you on the formula sheet. So here it is. First term times 1 minus r raised to the nth power divided by 1 minus r. Okay, that's not exactly true. The formula you will see in the reference sheet on the regions looks like this. A1 minus A1 times r to the n over 1 minus r. Do you see what I did and why I did this? I factored out A1. So instead of plugging in A1 twice, I just plug in it once, and then I'm calculating this expression. Okay, so it really doesn't matter which formula to use. I'm used to this one, and I recommend that you do too. So let's use it to solve this problem. Find the following sum: 2 plus 6 plus 18 plus blah blah blah. That's okay. First, let's look at the pattern. 2 to 6, 6 to 18. You can notice, even if it's not in the geometric series column, that there is multiplication by 3. So it is geometric series. So what do you know about this? You know first term is 2. You know it increases by 3. And you know the last term. Unfortunately, it's not very helpful because the last term doesn't even go into this formula. What we need to know n. Just like in the previous problem, really. So how many terms is here? Since you know that r is 3, you can do it by trial and error. 18 times 3 times 3 times 3 and see how many. Or if it's far away and it looks like pretty big number, we can set a little equation just like we did before. So the last term, nth, of geometric sequence, again, try to restore in your head how this formula came about for nth term. You start with the first one, and then you multiply times r, times r, times r. How many times? N minus 1 times. So we know the last term here, 4374. We know the first, we know the r. We don't know n minus 1. Guess what? It's an exponential equation because unknown is exponent. So we need to solve it as an equation divided by 2 both sides. Wait, so this becomes 2001.87 And now, again, either you want to do trial and error, or you can use logs. Take log of each side. So then, using the power rule, this n minus 1 comes down. So you have n minus 1 times log 3 equals log 2187. And if you divide both sides by log 3, you're going to get n minus 1, which is 7. So n equals 8. Unfortunately, I'm not even finished. My equation was to find the sum of these terms. So I need to rewrite my formula. Okay, I'm not rewriting it. No, I'm just using it. But I know that n is 8 now, so I can just plug everything in. My first term is 2 times 1 minus, okay, r is 3, n is 8 again, divided by 1 minus 3. Please calculate by yourself and check that your answer is 6560. Okay, so two formulas, one and the other. This will be given. This you need to understand where it comes from. Now, let's look at the first column that I left blank. There are many other sequences, a series, of course, which are not arithmetic and geometric, and you don't need to memorize them. But one thing that you need to understand about series is the summation notation. So sometimes we want to abbreviate this long sum, but using the following notation. For example, so the symbol, this zigzag symbol, it's a Greek sigma. Sometimes it's called sigma notation. Instead, for S, sum. So we say summing up from I equals 1 to, let's say, 4. A1, this is for instance, would be the sum of all terms from 1 to 4. So A1 plus A2 plus A3 plus A4. Let's look at an example. The letter doesn't have to be I. It can be K, N, whatever, anything. And this is the sequence I just made up. So I will need to add terms of the sequence starting with the K equals 2, ending with the K equals 5. So I'm going to write it down. When K is 1, oh no, I'm starting with the 2. So when K is 2, it's 2 minus 1 squared over 2. When K is 3, it's 3 minus 1 squared over 3. When K is 4, it's 4 minus 1 squared over 4. And finally, when K is 5, it's 5 minus 1 squared over 5. I'm not going to calculate it, you can evaluate, but I just want to label that this is for K equals 2, this is for K equals 3, and so on. So this is a pretty accurate and concise way to write this long expression. And it could be more than a few terms. It could be like 10 and 100 and infinite amount of terms. And this is why this notation is used. Okay, let's go to applications. Okay, here's the first problem. Let's say you have a plot of land that has a shape of a triangle. Don't ask why. And you want to plant tomato plants. And let's say in the first row you can fit 2 tomato plants. And the next one you can fit 3 more, and so on. So every row you can plant 3 more. So let's write 3 more on each row, following row. And let's say you have 8 rows. Okay, and we need to say that there are 2 on the first. Alright, so here's my story. How many tomato plants you need to buy? Okay, let's see. What's going on here? So in the first row, there are 2 plants. The next one, 3 more. Next one, 3 more. So clearly it's an arithmetic, now, sequence or series. What does the question ask? If the question asks how many plants will fit on the last row, that would be a sequence question, because rather than first, second, third, last row, how many? So that will be A sub 8. In other words, the 8th term of the sequence. But the question is how many plants we need to buy all together. So we need to add up all of these plants. So it's a serious question. So what we need to do, we need to find out what the sum is. And we know that n is 8. So write the formula. As soon as you realize it's an arithmetic series question, write down the formula. Remember the rainbow method. First plus last, we know it's 8, and half of 8. All right. So we know A1. Do we know A8? No, but it's easy to find because you have the formula of the nth term. So starting with the first one, you keep adding D, D, D. How many D's? One less. So you multiply it by 7. So A1 is 2 plus 3 is D times 7, so it's 21 plus 2, 23. And now we can use the formula for 8th terms. So first is 2, last is 23. I still don't want to divide it by 2. Times 8 over 2, which is 4 times 25. Oh, so good. 100. Okay, 100 plants to buy. Okay, one more problem. So let's say you put $100 in a bank, and let's say there's no compounding. So you decided to put 50% of the existing amount every time. How much money you will accumulate after 1 year? Okay, let's be very careful here. So first months, I'm actually going to kind of label it so we see what happens. First month, you put $100. Okay, second month, you put 50% more. So it's $100 times 1.5. I don't want to multiply. I want to see structure. Third month, whatever you had, the previous, I didn't formulate the problem correctly. I didn't mean 50% of the existing amount, but 50% of what you put last month. That's important, right? So now I want 50% more than this. So I already have this amount, and I need to increase it by 50%, so I need to multiply it by 1.5. In other words, I need to square 1.5, and so on. So at the end of the year, it will be 12th, and I'm going to add 100 times 1.5 to what power? Let's think. No power here. First power for the second year, second power for the third year. So for the 12th year, it will be 11th degree. Now, what the question asks, I don't want to know how much I put in the last month. I want to know how much is it altogether. So I need to add them up, and it will be a serious question once again. And of course, you recognize that it's a geometric series, because every term you can get from the preceding term by multiplying by what number? By 1.5, right? So it's a geometric series question. Let's write the formula. Do we know how many terms? Not yet. So let's just write the formula in general. A1, 1 minus r to the n over 1 minus r. Okay, how many terms do we have? Oh, we do know, it's 12 months, right? Yeah. So S sub 12 equals, A first is 100. Now 1 minus R. R is what? You multiply by 1.5, right? We raise to what power? This is really tricky. The last term here has 1.5 to 11th, but the formula says multiply by n, which is the number of terms, so it should be 12. So this is a tricky moment. You need to pay attention. 1 minus 1.5. Do I really want to calculate it? Okay, you do it, and then come back and check. So I got 25,749.27, assuming it's money, so around to the nearest hundredths. I hope it's right. Okay, so these two problems are not extremely original. They're typical problem, and the purpose of giving you two typical problems, one on arithmetic, one on geometric series, so you can easily recognize them. And that's it.